Okay, so this is my lab report on anaerobic respiration. Anaerobic respiration is respiration that happens without the presence of oxygen. So an is without, and aerobic is oxygen. So respiration that happens without oxygen. This experiment was done to test the result of different treatments or environments on the anaerobic respiration of yeast. So we looked at how different environments affected the ethanol production of yeast, which is indicative of the respiration levels. These treatments consisted of different water temperatures, which have been proven to have some effect on the effectiveness of yeast respiration. So, how this was done was a sugar water or a sucrose solution was prepared for each yeast, and the sucrose solution was heated individually for each treatment. So they were heated to 10 Celsius, which was our cold water, 20 Celsius, which was our room temperature water, and 35 Celsius, which was our warm/hot water. The control was the room temperature water, just because it's just kind of a standard for a solution temperature or a reaction temperature in like chemistry. So the yeast was placed into the solution and it was allowed to respirate for about 5 minutes, or exactly 5 minutes. And the data, because there were 3 different solution temperatures which produced 3 different data sets, is going to be analyzed using a one-way ANOVA test, which we'll talk about in a second. So this is our data. Take a look over here first. This is the slope produced by the ethanol. So basically the rate of change of ethanol production. Of course, they're all positive because respiration is going to happen. So we have right here, we have sort of an average of 1 right here, and then it increases a very large and significant amount by about 5. So you can really see that the ethanol is increasing in production over here. And then it increases a little bit more here in treatment 3. And this can be really clearly seen over here on the graph. So these are all the average values taken from here. And then these lines are the standard deviation values. And you can really see the huge increase from the cold water to just room temperature water. And then the smaller increase from the room temperature water to the hot water. The p-value was 0.07, and we're going to talk about that in a second. So you can see that, of course, the higher the water temperature, the greater in numerical value the slopes were. So there was a higher level of anaerobic respiration. There was a greater level of the increase of ethanol. And the higher level of respiration is explained by the molecule that, so this is explained because the hotter the water is, the faster the molecules around it are going to be moving, right? So in that reaction, in the respiration reaction, it makes the molecules move faster and therefore causes the whole reaction to go by a little faster. The p-value of 0.07 shows that this data may have had a significant chance of being a result of random chance rather than a direct result of the testing. So here's our conclusion. Although the standard deviations of the data provided for 2/3 of the trial were low, treatment 2 had a higher standard deviation, which represents data that was more spread out than usual, indicating possible random data. This is also kind of shown by the p-value, which was higher than 0.05, which indicates that the data may have significant chance of being a result of random chance rather than the significant question being tested. Therefore, the hypothesis was not proved correct. The things that could have affected this solution or this conclusion were the possibility of the non-activation of the yeast used in the experiment, which would have affected the ethanol production, and the inability to maintain a consistent water temperature while time passed during the ethanol recording session. This could have affected the results because the temperature changing could have produced results that were not faithful to the original temperature. So just to kind of talk about this a little bit, non-activation of yeast is especially common in like overall regular baking, and it could have affected this currently, where some of the yeast or all of your yeast, which I don't think the latter happened in this, is dead, so it can't produce anything despite being like physically there. So it wouldn't produce as much ethanol as a yeast sample that is completely alive would produce. And then the consistent room temperature or the consistent water temperature, just kind of self-explanatory. You want a consistent temperature because that's what you're trying to measure. Um, and so if it went back to room temperature, if it got a little warmer, it could have affected the ethanol production. So why is this relevant? Why should we care about ethanol production or how good yeast works in different temperatures or different temperature water? And it's basically from you can take it from a manufacturing perspective where people want their bread different consistencies. They want it fluffier or they want it more dense, and how much yeast that is produced or how much it's or not yeast, how much ethanol is produced or gas, um, or the respiration rate affects how fluffy the bread is. Or if you want less, then you would use like a colder water to get more of a dense bread, right? Same thing with alcohol. The ethanol production in alcohol, sometimes you want more, sometimes you want a stronger drink, and sometimes you want less. And so if you're a manufacturer, knowing what temperature to bloom your yeast at or what to keep your solution at, ferment your alcohol at, is important because you want a specific percentage of ethanol in that alcohol. Here's just the reference. This is what I talked about in the second slide, where anaerobic respiration has been proved before to have a effect on the rate, or the water or the water temperature was proved to have a effect on the anaerobic respiration rate. Yeah, that's it.